Okay, this is exercise 9, Stewart Advertising, and it is they did a regression for 12 months on their data, and they're looking at the number of customers serviced, and I'm not sure what it's supposed to be related to. Oh, travel and entertainment expenses related to the number of customers that they saw, to see if it's really a function of that, or maybe it's just a couple of customers. You never know about that. So this is the result. And there's a lot to regression, but we're only going to look at a couple things. But it's really fun if you've ever got some data to fool around with it. This tells us that there are three different measures we're going to look at, and this is one of the most important ones. Is right here. That's the R squared, and that tells us. I'm going to write this down. The percentage of variance explained by the model. Okay, and 1 is perfect. But know that this depends on what field you're in too. In some businesses, like if you do accounting research, if you get an R square in some cases of like 0.3, that's pretty good, okay? At least it explains 30%, and maybe you're at the beginning of a model and just trying to figure things out, so you won't necessarily have a large percentage of the variance explained, okay? But this is right here, that's the number we're looking for, an R square. This is almost a perfect correlation, okay? That's I shouldn't use that word, but it's really, really high. On the ANOVA stuff, we're not going to use anything right here, but the other thing we're going to look at is the p-value for the variable, okay? And so the variable here must be spending, right? Number of customers, that's what it must be. That's what this is. And the p-value should be less than 0.05, and what that means is that there's less than a 5% chance of this variable not being significant. Okay, like if it's a 50-50 chance, you wouldn't want to take a chance on it. Actually, we normally wouldn't even go up above something that's 10%. Okay, but again, it kind of depends on the situation. All right, and the other thing that you should know is that your intercept is right here, 756.9. That's your fixed cost. Okay. And this X variable, which is really number of customers, okay, is 676.49. Okay, and do not round these numbers. Okay, say round to 4 places. Let your reader make up their own mind. Okay, these are not numbers that are rounded all the time. So just leave it big. I mean, it doesn't have to be 6 digits big, but leave it pretty big. So we just identified the R square and the fixed cost and the variable costs, okay, from this regression output. Those are the coefficients. And the cost equation line is total cost equals 756.9 plus 676.49 Q. Okay? This is 0.9, so I didn't round it up anymore. And then it asks, is there a strong correlation? I wouldn't use this word. I would say relationship. Okay, between the number of customers and the travel and entertainment expense, the answer is yes. Okay? All right, that's it. That's all you've got to know about regression, are those what's on this page.